homework time, homework time. Here we go, homework time. Lesson 11 homework. Good old addition. So let's start by jotting our names down at the top. I'll put my name, you put yours, and let's both put today's date. I'll write today, you write the actual date where and when you are. And now we're taking everything we've learned about place value and putting it to use in addition. Standard algorithm simply means the usual way of figuring things out. The customary way of doing things. The normal way of doing things. Standard algorithm. You'll actually see those words a lot here in Eureka Math, so I want to point that out to you. It's not one of those things you can just say, okay, whatever. It's going to be all over. So algorithm is one of those wonderful words too. So let's look at 1A, where we'll be solving the addition problems below using the standard algorithm. Well, it simply means adding with the regrouping. So we'll start by adding 9 and 4. That's right, it is 13. So the 3 goes in the 1's place, and the 1 goes in the 10's place. And doesn't that make sense? Yes, indeed it does. So 1 and 0 and 4 make 5, with nothing to regroup there. And then we have 9 and 0 make, got it, 9. 7 and 1 make 8, yes. And we'll place our comma. And we stop and ask, does this make sense? Well, this is about 8,000, right? In fact, let's write a little estimate here, just for this first one. We won't do it for all of them. So this rounded to the nearest 1,000, you can do that quickly and easily. Now, after many lessons of practice, is 8,000. This rounded to the nearest 1,000 is 1,000. And if we were to add those, we'd get 9,000. And doesn't our sum round to 9,000? Sure does. And even if it rounded to 10,000 or 8,000, we'd still say, hey, we're in the right ballpark there. We're in the right zone. It sounds good. It makes sense. Usually when you make errors, they're egregious errors. They're way off, and you'd catch it easily. Let's look at B. Remember, they always start off easy, so that was the easy one, A. So B, step it up a little. See, we have one of the numbers is in the 10,000s. So 9 and 0 make, got it, 9. 0 plus 4, peasy, right? 4. Okay, now we're going to have some regrouping. We're going to have 2 regroupings in this one where we only had 1 in A. So 9 plus 7 makes, you got it, 16. Place the 6 and regroup the 1. And 9 and 7 still make 16, plus the 1 more is 17. Place our comma there and regroup the 1. 1 and 2 make 3. And here you can even do the estimate quickly in your head. That's about 30,000, that's about 10,000. 30,000 and 10,000 make 40,000. Is our sum about 40,000? Yes. You see how the rounding and the estimating help you check your answer quickly and easily. All right, now you can see we're stepping it right up. We have a number in the 100,000s and a number in the 10,000s. And at a glance, we could see we're going to have 1, 2, 3 regroupings instead of 1 or 2 like we did on A and B. Well, let's jump into C. 9 and 9 together are 18. We place the 8 in the sum, regroup the 1. 1 and 0 and 8. Got it, 9. Well, we just did 9 and 9. Here it is again. Still 18, isn't it? Nothing's changed. Place the 8, regroup the 1. And 1 and 7 and 2 make, yeah, that's one of our make 10s combinations there. And don't forget the comma, regrouping the 1. And 1 plus 2 plus 4, 7. Very good. And lastly, we have this 8 with nothing here. We could say 8 plus 0. We could just say 8 is 8. So again, does this make sense? Round this to the nearest 10,000. 830 plus 40 is about 870. That's exactly where our answer is. Okay, so that's 1, A, B, and C. Let's keep on rolling like a river. All right, D, E, F. That spells deaf. All right, I'll stop there. Okay, let's look. Now you see we have in these numbers, we're going out to the hundreds, thousands. Just one of the numbers is in the 10,000s. We can tell in a glance we're going to have mucho regrouping here. So let's dive right in. 5 and 5 make 10. We place the 0, regroup the 1. 1 plus 0 plus 4. You got it, our 5. 2 and 8, that's one of our make 10 facts, right? Make 10. 2 and 8 make 10. Place the 0, regroup the 1. 1 and 9 make 10, we know that at a glance. 1 more is 11. Place the 1, regroup the 10, and don't forget a little comma here. 1 and 8 and 1, again, make 10. They're on a roll here. All right, so we place the 0 in the 10, regroup the 1. 1 and 2 make 3. And you might, here's another way to check your examples, is to just kind of like, if you are used to these patterns, you see 289 and 11. Oh, 89 and 11 make 100. You see that? So 289 and 11 will make 300. Your answer checks out. See, so there are different ways of, different logics you can use, different algorithms you can use to check your work. Let's take a look now at E. All right, let's jump right in with some addition here. 2 plus 9. 10. Okay, you got it, 11. Place the 1, regroup the 1. 1 and 8 make 9, plus 4 is 13. And if you see more easily that 8 and 4 make 12, plus 1 is 13, that's great. In fact, here we see, 1 and 9 are 10. 10 and 8, 18. Good. See, it's easier to do it that way. And maybe on this one you say, okay, well, I know certain facts. I know 1 and 4 make 5, plus 7 is 12. Or maybe you're going to add 1 and 7 make 8, plus 4 is 12. It's 12 any way you slice it. So you can change the order of the add-ins because addition is commutative. All right, and so we've placed the 2 and regrouped the 1, added in our comma there so we don't forget it. 1 and 4 and 1, easy, 6, right? 5 and 1, also 6. And here's the super duper easy check to make sure you're at least in the right ballpark. Just look at the 100,000s because they're both in the 100,000s. It's easy. 5 and 1 makes 6. Okay, like we're in the right ballpark. We're not way off here. 500,000, 100,000, 600,000. We know we're not way off. If we were in the millions, you might want to stop and look things over again. All right, let's jump over to F. 3 and 7 is a make 10 fact, right? 3 and 7 make 10. So place that 0, regroup the 1. And this is another instance where using the commutative property of addition helps us add more easily. I see 1 and 9 make 10. And adding 8 to that is 18. So that might be an easier ways to change the order of the add-ins. And again, what do we have here? 1 and 9 make 10, plus 8 is 18. There we go again. And now look again at this make 10. 1 and 1 are 2. 2 and 8 make 10. It's all over the place, folks. And don't forget our little friend comma. 1 and 5 and 2. 1 and 5 are 6, plus 2 is 8. Nothing to regroup. Sometimes when you have a lot of regrouping, you get into that automatic regrouping, even if there's nothing there, okay? And I'll point something out to you in a moment about that. So 2 and 1 make 3. If you had accidentally just regrouped because you were regrouping in every place when you weren't supposed to regroup, you would have ended up with 480,000 here, and that would not have passed your check because you would have looked at 200,000, 100,000 is 480. That would have made you say, let me look a little more closely just to be sure. But here we can say, okay, 200,000, 100,000, 300,000. Okay, this makes sense, and we can look at the 58 and 21 and know that those are less than 100. We don't have to even know exactly what they are. We can just say it's less than 100. So this answer makes sense. Let's round up number 1 with our GHI. All right, jumping over to the GHI. You can expect things to maybe get a little trickier here because you usually start off easier. Let's see what we have. Okay, 6 and 8 make, you know that fact? 14. Good. Now let's write the 4. We'll place here and regroup the 1. Now this is the first time we've seen this, so hopefully it's not too confusing, but you can see you're adding that regrouped 1 to 0 and 0. 1 plus 0 is simply 1. And there's nothing to regroup here, of course. So now we're looking at 9 and 8, which we've seen several times on this page already. Still 17, you got it. Regroup the 1. 1 plus 3 is 4. 4 and 5 make, you got it, 9. Placing the comma there with nothing to regroup, it's just plain old 9. And now 8 and 3, and this is the first time we've seen this kind of happenstance. 8 and 3 make 11. Now, if I were to regroup the 1, well, there's nothing in the 100,000s place, so it would just kind of be a waste of time. And so what we do is we say, okay, it's 11. 8 and 3 make 11. If you were to regroup the 1 and then just place in the 100,000s place, it wouldn't be wrong. It would just kind of be unnecessary. You get the same answer with one less step. And does this make sense? 80 and 30, let's even just look. 8 and 3 make 11. 80,000 and 30,000 make 11 10,000s. 8 10,000s, 3 10,000s, 11 10,000s. This checks out. All right, now we see in this one we have lots of 9s going on. Like that's going to mess us up. Ha! We can do this. 9 and 9, we know that fact. It's, you got it, 18. Place the 8, regroup the 1. 9 and 1 make 10. 4 more are 14. Very good. Place the 4, regroup the 1. 1 and 9 still are make 10 fact. 10 and 8, 18. Place the 8, regroup the 1. And here we have, again, that make 10 with 1 more is indeed 11. Place the 1, regroup the 1. Let's not forget our comma friend. And now I'm going to go use the commutative property of addition again to put them in different order, make it easier to add. 1 and 9 make 10. 8 more is 18. You don't have to do it that way, it just might help you. And I do have 1 to regroup there, so 1 and 2 make 3. Now, check this out. Let's round to the nearest 100,000. This would be 300,000. This would be 100,000 to the nearest 100,000. 3 and 1 make 400,000. Does our sum round to 400,000? Yes, indeed it does. So we're good. Well, let's go over to I. 0 and 0. Every day, all day make 0. 0 and 0. Still 0. Can you believe it? 9 and 1. That's one of our make 10 facts we keep seeing here. And regroup the 1. And now here you see 1 and 4 make 5. 5 and 5 are. Yeah, that's yet another one of our make 10 facts. Regrouping that 1. I like to stop at this point and place that comma. You could do it afterwards, doesn't matter. And here again I'll use the commutative property of addition to make the addition a little simpler. Oh, I see here a little pattern. 1 and 4, just like in the last one, make 5. 5 and 5 are 10. And regroup the 1. And here again we see a make 10 fact. See, 1 and 2 are 3. 3 and 7 make 10. And so I go ahead and place that. And I need a comma here, right? 1, 2, 3, comma, 1, 2, 3, comma. And you see they made this one come out to an even 1 million. Cute, huh? Can you believe there's only 2 examples in tonight's homework? But there are many parts. So let's go on to number 2 and get things done. Okay, here we are on 2A. Let's read the instructions. Draw a tape diagram to represent each problem. Use numbers to solve, and write your answer as a statement. So you see with our read, draw, write, we'll be reading the question, drawing a tape diagram, And then the writing involves both the numerical writing, the numbers doing the math, and then a sentence, a statement that says, here's what the answer is, which is oh so important to do. All right, so let's read 2. At the zoo, Brooke learned that one of the rhinos weighs 4,897 pounds, one of the giraffes weighs 2,667 pounds, one of the African elephants weighs 12,456 pounds, and one of the Komodo dragons weighs 123 pounds. Okay, so just to get that in our heads, we have rhinos, giraffe, well, we have a rhino, a giraffe, an elephant, and a Komodo dragon. We have 4 animals we're talking about here. Okay, just so we keep track here. So now our question is, what's the combined weight of the zoo's elephant and giraffe? Okay, so we're only looking at the elephant and giraffe. And because we're adding them together, and there are different ways you could draw this tape diagram, but I'll show you my preferred way. We're adding them together. We can draw one tape that combines the two so that the drawing actually shows we're putting the two together. So if I were to draw out a piece of tape, I believe this is why they're called tape diagrams, right? Looks like a piece of tape. And you could use a bracket, but I'm going to write inside of the tape. I kind of like the way that looks. That we need the elephant. He's 12,456 pounds. And then the giraffe is smaller, so I'll have a smaller piece of tape, relatively proportional, doesn't have to be exact. He is 2,667. And now, all together, that will give me their combined weight, which, hey, let's call W for weight. So I could actually say the weight, which is W, will be the 12,456 plus the 2,667. And when I combine those, that will give me the weight. All right, good. Straightforward, right? All right, so it says use numbers to solve, so let's actually solve it. And we already wrote out here what we're doing is adding these together. 12,456. I'm now going to write it vertically. Here it's horizontal, side to side, but that's a little more difficult to do. Could do it, it's just not worth the trouble. So then adding to it 667, 2,667. Really, that's a 6, folks. All right. And adding. So let's add. Ready? Here we go. 6 and 7. 13. Place the 3. Regroup the 1. 1 and 5 make 6. 6 and 6 are, got it, 12. Place the 2. Regroup the 1. And here I see a make 10 fact. 4 and 6 are 10. 1 more makes 11. Place the 1, regroup the 1. 1, 2, and 2. 2 and 2 are 4. 1 more is 5. Very good. Don't forget our comma friend. And we just have a 1 in the 10,000s place still. Does this make sense? We can do a mental estimation. 12,000 and 2,000. It's 14,000. This is 15,000, so we're in the right ballpark. If you got something totally wackadoodle, you'd want to go back and take a closer look. And now we just simply need a statement. So we'd say answering the question, which is what is the combined weight of the elephant and giraffe? So the combined weight and you should spell all this stuff correctly. Why? Because the words are right there. Of the, what are we looking at? Yes, an elephant, an oliphant, and giraffe is 15,000, right? 123. Yes, don't forget that, pounds, and we'll look at the abbreviation for pounds is LBS, although you technically could use LB, but we won't. And so what we discovered, by the way, I can write this over here just for whoas. W, the weight, the combined weight, is 15,123 pounds. And I'm just going to go on a total digression here because that LB as an abbreviation for pound is kind of weird. So it's from the Latin word libra, the same as the horoscope sign Libra, who's holding a set of scales. So Libra simply in the Latin root means weight. And so it means weight. So when you say pounds, you're saying how much it weighs. So our abbreviation LB, which has no relation to the word weight, is from the Latin libra, which is simply meaning weight. There you go again. All right, so we have read, we drew, we wrote, we solved, we gave a statement that is neat and complete. Let's go on to 2B and C. All right, moving on to 2B and C. You notice I made a notation here because although on your sheet you can see it, I don't have it here, but the weights of each animal, I just made a note: the rhino, the elephant, the giraffe, the Komodo dragon, because we'll need some of those for these. So what's the combined weight of the zoo's African elephant and the rhino? So now we're looking plus for elephant, but rhino. Well, we used W last time as our combined weight, so let's use X. Why not? So we're going to say X is going to be elephant plus rhino, right? What is the elephant? Or how much does the elephant weigh? 12,456 pounds. And the rhino weighs in this corner, the rhino at 4,897 pounds. And then when we're done, we could say what X is, what that combined weight is. I did this first this time, so then it might be more helpful to do that first. So when you go to draw your diagram of tape, your tape diagram, you know exactly what you're putting in there because we're combining the elephant at 12,456 with the lesser weight of the rhino, 4,897. And all together, that combined weight, we are designating with the variable, using the letter to represent an unknown quantity of X. So now let's actually do the math. Here we go. All right, so we're adding together 12,456. I'm gonna write it vertically now, up and down, so it's easier to do the math. We're adding to 4,897. And we are adding these. Good. Okay, let's do it. 6 and 7 make. Got it. 13. Regroup that 1. I see a make 10 fact here. 1 and 9 are 10. 5 more make 15. Good. And 1 and 4 are 5. Plus 8. 5 and 8. 13. And if you happen to look at that and think, oh, I know 8 and 4 are 12. 1 more is 13. Hey, that's a great way of doing it too. 1 and 2 and 4. That's 3 and 4. Makes 7. Place our little comma friend. And we just have that 1 in the 10,000s place. So our combined total is 17,353 pounds. So our statement will simply say the elephant, I'm going to make my statement a little shorter now because I just feel like it. The elephant and rhino weigh how much? 17,353 pounds together. Bing, period. There we go. We read, we drew, we solved, we wrote, we conquered. Now we're putting together 3 of the animals. So our tape diagram will have how many sections? Yes, indeed. You got it. 3 sections. Elephant, rhino, giraffe. Okay, so let's start with the tape diagram this time, just for variety's sake. All right. And I could draw 1 section at a time, but I can kind of map this out visually and say, okay, I'm going to have enough room here to write them all. But I could do 1 section for the elephant, then add on a section for the rhino, add on a section for the giraffe. I've just been doing this long enough I can see what it's going to look like. So our elephant is still 12,456. Our rhino clocks in at what? Yep, still it's the 4,897 pounds. And now we have Mr. Giraffe, and he is 2,667 pounds. And we used W, then we used X. Hey, what do you say we use Y as our variable here? Y. And we know that Y is going to be the elephant and the rhino and the giraffe. So we're adding, that's right, 12,456 plus 4,897 plus 2,667. And then we can place here what to prepare us for our actual sum. Now you could do this in 1 step or 2. We could add these 2 numbers and then just add this to it, or we could add all 3 together. But guess what? What'd you just realize? Yeah, in B we already added the elephant and the rhino together. We already know what the sum of these 2 weights are. So hey, let's use what we've learned. We know that they are already 17,353 is the elephant and the rhino together from part B. Boy, ain't we so smart. And now we just have to add the giraffe to that. And if you missed that, it's okay. You just be making more work for yourself, which we all do. All right, so now we can add these up. So 3 and 7 make 10. And you might see here, 1 and 5 are 6. 6 and 6 are 12. Yes, regroup that 1. 1 and 3 are 4. 4 and 6. That's another one of my make 10 facts. All right, and here you might see that 1 regrouped and 2 are 3. 3 and 7 is yet another make 10 fact. And don't forget the comma. 1 and 1 make 2. And does this check out? 17,000. And this would round to the nearest thousand as well to 3,000. 17 and 3 make 20,000. Yep, this checks out. All right, so now we just need a little statement action here. The elephant rhino, and again spelling these all correctly because the words are right there, and giraffe weigh how much? Yep, there it is, 20,020 pounds together. I don't know, maybe you're putting them on a train, in separate train cars. You need to know how much the weight is, how much the train needs to pull. And we could say now that y, our unknown, indeed is 20,020. All right, now we're ready to move on to our final example, 2D. See you there. Okay, notice again I've noted for us here the, why don't we do that? Why don't we draw a little circle around it? The, what the dragon and the rhino weigh. So we have that on the screen for us here. Okay, so now we're looking for the combined weight of the Komodo dragon and the rhino. This one's actually easier than the last one, isn't it? Yeah, because we're just adding 2 of them. All right. So let's do the rhino first. That's the bigger one. 4,897 in our tape diagram. And then the much smaller part is 123 pounds for the Komodo dragon. Well, we did W, X, and Y. Let's go with the flow, and we'll call this Z. All right, so we know that the combined weight, which we're calling Z, is going to be the dragon and the rhino, which is, to be more exact, 4,897 for the rhino and 123 pounds for the dragon. And then we can put our actual combined total here. And we're just combining these weights. The tape diagram makes it clear. So we're just simply adding here 4,897, at which we are adding to 123. And normally the most difficult question is last, and this one does have some regrouping that really shouldn't cause you any problem, but maybe they thought it would. I don't know. All right, 7 and 3, we know that's, you gotta make 10 fact. All right, so we place our 0, regroup the 1. We see 1 and 9 make 10. 2 more are 12. Place the 2, regroup the 1. And here again, use that commutative property of addition. 1 and 1 are 2. 2 and 8 make 10. We know that. Place the 0, regroup the 1. 1 and 4, you got it, 5. If we were to do an estimate here, because our smaller number's in the hundreds, we'd actually have to do it to the hundreds. So this would be 4,900, and 100 is 5,000. Our sum rounds off to 5,000. Yeah, totally checks out. So now we just need our statement. We read, we drew, we wrote our solution, and now we need to write an actual answer. The dragon and rhino. Again, learn to spell these words. It's right there, right above. You can spell them correctly. Weigh how much? Yes, 5,020. And don't forget, you always have to label it with the units. Pounds together. And then back over where we have Z equals, we can say, hey, it's 5,020. Okay, homework time is over. Homework time is done. Enjoy. See you next time.